So 4.3 is solve systems of linear equations by addition or elimination. It doesn't really matter what you call it. There is a fourth strategy, which we will not cover in this class, but you will cover if you ever take 1010, okay? We use this particular method when the equations are structured a specific way. And the way that they're usually structured is in that standard form notation, okay? So standard form is, this is still abstract, but it's ax plus by equals c, which we've seen. We've seen equations like this, but usually when we do, and of course a, b, and c in this would be numbers, right? It could be negative 5x plus 3y equals 18. And then in the past, we've changed that. A and B and C would be numbers, and in the past, we've changed that into slope-intercept form because when we graph, we only need those two things, the slope and the y-intercept. But now, of course, we're not graphing these, we're solving these with some serious algebra here, or it's a good start to some serious algebra anyways. But the idea with everything that we're going to be doing today is to force the equations to be what we want them to be. Now, we're going to do all that without changing the value. So just like in the past where we've seen a change of 1/2, maybe in the past we've written it as 2/4 so that we could add or subtract fractions, right? It's the same idea. Or maybe you went from 2/4 to 1/2 so that it was considered simplified. It's not that you're changing the value of the fraction, you're just changing the way that it looks. We're going to be doing that with the equations using essentially what we'll consider principles of equality, right? Because whatever you do to one side of the equation, you got to do to the other side of the equation. And as long as we can continue those principles of equality, we can change the way that the equations look without changing their value. So this is kind of I don't even know if this is a formal process, but you want the two equations to be in the same form. Usually it's in this format. You could change both of them into slope-intercept form, but usually if you do that, then the strategy would become more of a substitution kind of thing, because then you got y equals something. So we're generally looking to change our equations into this standard form notation. And then what we got to do is we got to, multiply the equation by non-zero numbers. So the idea with this second step here is to force one set of coefficients to be opposites, okay? Now remember, the coefficients are the numbers being multiplied by the letters. And it doesn't matter if you're doing this with the x's or the y's. It does not matter. You just need to force those two coefficients to be opposites. So if, let's say I said, hey, I want to eliminate the x's because for some reason I just hate x's so bad. Then if this was like a 5x, then I would need the other coefficient to be a negative 5x. Okay? This is almost like forcing denominators to be the same when you operate, or at least add and subtract with fractions. I don't know, that may be kind of a stretch though, but in my mind that seems to make sense. So we're going to force those two, whatever variable we choose, right? And in some cases we'll see that it may be easier, it may be more expedient to choose to eliminate the y's. In some cases it may be more expedient to eliminate the x's, more convenient I should say. So there is a little bit of analysis in the beginning, just like we saw with substitution, right? It's like, which one do we want to substitute? If it's easier to manipulate equation a certain way, then we choose to substitute a specific variable instead of the other one. But we got two to choose from. After you get those coefficients to be opposites, you're going to combine the two equations. And what I mean by that is you're going to add them together. Now, you'll know if you need to add or subtract because we're going to put these in columns, right? Like you got ax plus by equals c. If I wrote another equation and said it was, I'll just keep going, d, a, b, c, d, e, f. So maybe the second one was dx plus ey equals f. Actually I'll change the ey into a minus just so we can see what that would look like. So if there was a minus right there, then you'd say I'm going to take the x's. See how I've kind of listed these in columns now, which is kind of a precursor to our, what they call matrices. That's the other strategy. But you'd take the a and the d value and add those together. Now this one, you'd say you could add them together, but I'd say b minus e on that one. So if it was like 3 minus 2, then you'd subtract, okay? And then, of course, you'd combine by adding the two constants. So that's one of the reasons why they call this the addition method, because you're adding the two equations together. But by adding them together, once the two coefficients are opposites, so let's even look at what that would be like, right? So if I force this coefficient to be 5 and this one to be -5, oh, that's a 2, but this, let's say it's a -5 right there. See, when I go to add these two equations together, which I can do, these are going to zero out. Okay, and then all you're left with is an equation that has just y values. And we already know how to solve equations from Unit 1, Module 1, so hopefully we would feel pretty comfortable doing that, okay? So that would be the third part. The fourth part is then you solve for that variable. Okay, so take the sum, take a new equation, yeah, because you're going to get this new equation with just one variable. In this case, this example, you'd have solved for the y's. And you solve for the y, okay? And then, once you get the y value, then you go back to either one of the two equations, replace the y value in there, and then solve for the corresponding x value, just like we did with substitution, okay? And then the last thing you'd want to do is just check both equations to make sure that they would be a true statement, which means that the ordered pair, whatever it is, would be on both lines if you were to graph them, okay? And again, even if you were to just graph the two equations, it would just be the intersection. But as of now, the homework's going to say you got to use elimination or addition. Same method. So here we go. Let's look at this system of equations. Two systems of equations. These are already in standard form for linear equations, so I'm not too worried about changing the form, all right? Now, it would be nice to see the coefficients on this one. So the x's, I got 1s, and then the y's, I got this -1, and that's a +1 right there. Now remember, with the second step here, we would usually want to force one of the coefficient sets to be opposites. But here I have one, and again, this is where we don't want to just jump into things and say, I will always eliminate the x's, because right now, I can eliminate the y's right now because the coefficients are already opposites. Now, does that mean you have to do that? No, if you chose to eliminate the x's, you could, okay? But it's going to be a little bit more work. As for me, though, I'm just going to go ahead and I'm going to add these two together. And just like we would usually with solving equations, we have to make sure we're combining the like terms, okay? So I'm going to take my x's and combine those. So that's 1x plus another x, that would be 2x's. Okay, now, this is where we get the elimination. -1y plus 1y, that would zero out. Or, I don't know. If you wanted to write eliminate, that's fine. It's just kind of a long word. So yeah, I've combined the x's here, I've eliminated the y's, and you know, if you want to show eliminated right there, that's fine. It's just kind of a long word, so I'm not going to do it anymore. But then I'd have the constants right there. That's 6 plus 2, and I forgot to put the plus sign there. Hopefully that's okay. But remember, we're combining, so it is addition. 6 plus 2 is 8, and then the equal sign just remains there. Okay, so see this new equation is pretty easy to solve. It's a one-stepper. And so to solve this one, I'm just going to divide both sides by 2. And what do you know? That's a phantom 1x, x equals 4. Okay, so already right now, I got an ordered pair, and I know the x value, or I think at least the x value is 4. Okay? So, what was that? The first 4 steps, right? It's just that we didn't need to force the equations to be the same format, and we did not have to force the coefficients to be opposites. So pretty convenient, okay? But now that I know the x is 4, I got to go back to one of the two original equations, x minus y equals 6 or x plus y equals 2, and I need to find the corresponding y value that will make it true. I'm going to choose the second one, and the reason that is because it's going to be less work. I don't want a negative y, which is the variable we're solving for, so I don't want to deal with that -1 coefficient. Could you? Yeah, you should get the same value, by the way, okay? But we'll get to that. So I'm going to choose the second equation to solve for the corresponding y value, x plus y equals 2, and I'm going to replace the x now with 4. So I got 4 plus y equals 2, and this becomes the equation that I got to solve, where I would then subtract 4 from both sides. And yep, see how that gives me the y automatically right there. That zeroes out the 4. I'll drop my y equals 2 minus 4 is -2, and that should be my y value that corresponds with an x value 4. But last thing we'd want to do is just to make sure that this would be a true statement, right? So let's go to the first equation, and we're checking for truthfulness here. So there's a good question mark on both of these. And I say the y value is -2, right? So if I put -2 there, and 4 in for x, 4 minus -2 is 6. That ends up being plus, so that's true. First one ends up being true. The second one, let's find out. So the x value is 4, and the y value is -2. 4 plus -2 is 2, so that one also is true. and now I know for sure that the equation, or the ordered pair rather, that we found is the actual solution to this equation. Again, this is kind of a nice starter problem because we didn't have to do any funky business at the beginning, moving stuff around with principles of equality. And the coefficients of the y's specifically in this one were already opposites, which made, again, to me, I think that makes it pretty convenient. All right, for this problem, again, just with a little quick analysis, you can see that there's no need to change the any of the coefficients because, I mean, you can start with the y's right here. They don't match, or they're not opposites, but the x coefficients are. So that means that we are ready right now to add the two equations together, okay? Remember that it's not going to affect where the equal sign is, but I got the 8x's minus 8x's. That will zero that out right there. It eliminates it. And then I'm just left with some y values, 5y's plus negative 9y's. Like I said before, you could make that just 5 minus 9y, and that would work. You're still going to get negative 4y either way. Then you got a 62 plus negative 86. I would just say 62 minus 86 to get negative 24 right there. And then we're ready to solve for y by dividing both sides by negative 4. And this tells us that the y value is 6 in the ordered pair. Okay, so there's my ordered pair right there. I believe that the y value right now is 6. All I got to do at this point is to go back to one of the two equations and solve for its corresponding x value. Now for me, I'm going to choose the top equation just because there's not so many negatives and minuses as there are in the second equation. So I'm going to start with 8x plus 5y equals 62. But now, as of right now, I think the y value is going to be 6. So if I replace the y value with 6, then we'll see if this gives us a true statement. But keep in mind as well why it works for both equations, because remember, whatever ordered pair we comes up needs to make both equations true. So it doesn't matter which one you solve for x. Again, you're just replacing the y value there. So solving here, 5 times 6 is 30. So that gives us 8x plus 30 equals 62. And I want to zero out that 30, so I'm going to subtract 30 from both sides. That's going to zero that out. I'll drop my 8x's there, which now equals 62 minus 30 would be 32. Now I'm ready to divide both sides by the coefficient of 8, which tells us the corresponding x value should be 4, if we've done that correct, okay? So the last thing I'm going to do, and I'm just going to plug this into my calculator, I'm going to do 8 times 4 plus 5 times 6, just to make sure this gives us a true statement. So 8 times 4 plus 5 times 6 is actually 62, so the first equation there does check off. It's true. And then I got negative 8 times x is 4 minus 9 times the y value, which is 6, and I push enter, and I get negative 86 right there as well. So the second equation also checks off, and then I know for sure that this ordered pair is the solution to both equations, or, again, if this were a graph, this is the point of intersection of the two lines, if you were to graph them. And again, we would want to look at both equations. Take your time doing this. Okay? And I know maybe the homework may take some time, okay? But just right off the bat, I look at the two equations. Are they in the same format? Yes, they are. Okay, ax plus by equals c, ax plus by equals c. Okay, so that's fine. So I don't need to change the format of the two equations. But what I do need to do is to force one of the two sets of coefficients to be opposites. Okay? So it doesn't matter which one you choose. Like if I were to look at this, I would probably have chosen the x's to eliminate myself. But you could also say it's easier to eliminate the y's because they're already opposite signs. You just need to force this one coefficient to be a 3. All right, it doesn't matter. It doesn't really matter. Okay? So let's eliminate the y's then. So I will show that phantom 1. There's the negative 1y. And we are choosing to eliminate the y's. Okay? Did I spell eliminate right? I don't know, but I also don't care. So what I'm going to have to do, first give myself some space, is what I would really like is for this coefficient of y to be a negative 3. It's already negative 1, so that's not bad. And so I can get it to match with 3's and there be opposites. That's going to be pretty convenient, okay? Because what I'm going to do with this equation is I'm going to multiply again, I'm multiplying both sides by a value, and so I'm showing parentheses here to show that it's pretty much like distribution. All right, so what am I going to multiply it by? Well, I want that, again, I'm just focused on this coefficient. I don't care how it's going to affect these other two values right now, okay? I just want to affect this one, this coefficient of y, and I want it to be a -3, so I'm going to multiply it by 3. How did I know to multiply by 3? Because 1 times 3, or -1 times 3 is -3. It gives me that opposite coefficient, okay? So this is going to change the look of that equation, although it will not change the overall value of the equation. Because I'm going to multiply these two terms by 3 on the left. I'm going to multiply this term on the right by 3. Whatever you do to one side, you got to do to the other side. I'm just performing a principle of equality, showing it slightly differently. So 3 groups of 4 x's would be 12 x's. And then 3 groups of -1. This was kind of the goal. That gives us -3 y's. And then 3 times -13, that would be -39 right there, okay? We didn't do anything to the top equation, so that one just stays the same. 2x plus 3y equals 11. But now we can see that we have forced on our own the coefficients to be opposites. One is 3, one is -3. So now I can go and I can start adding these by like terms. Okay, so I got the 2x's plus the 12x's, which would be 14x's. The 3y minus 3y, that's going to be 0. That zeroes out, just like we wanted it to, because it eliminates. And then 11 minus 39 would be -28. So I got 14x's equals 28. Last thing I'm going to do here is just divide both sides by 14. And I get x equals -2. So there's my ordered pair, the x value of my ordered pair anyways. We just found it. It's -2. We'll ensure that it is -2 later, okay? So I do have an x value, and now I go back to the two equations, which it is kind of sloppy just because of the distribution or whatever. But we got to choose one of those to solve for its corresponding y value. And I don't really care which one I choose. I'll choose the top one. Now, we already dealt with the top one, right? Yeah, that's true, but I'm going to do it again because we just found an x value for that top equation. We just need a corresponding y value that will make it true so that the ordered pair makes it a true statement. Remember, that's the whole idea. And so I'm going to replace the x here with -2. And I'm going to solve for its corresponding y value. So 2 times -2 is -4. And then I still have the plus 3y equals 11. So at this point, I'd add 4 to both sides. Oh, it's going to make that nice as well. Zeros that out. I'll drop my 3y, which equals now 15, and divide both sides by 3, and I get y equals 5. So x value is -2, y value is 5. And I'll check this. For the sake of time, I probably won't check in the future, but we just found that the y value is 5, right? So let's check this one, and then we'll check this one. And we see the x value is -2. At least we think it is. And we're going to check this, both of these, for truthfulness, okay? So this be -4 plus 15, which is 11, so that's true. You could use a calculator to do this, but it's not too bad. And then 4 times -2 is -8, minus 5 is -13, so that's true as well. Since we see that both are true, now we know that this is the actual solution to the system of equations. Because we don't want to, I would highly recommend not using the equation that you manipulated like I did here in red. Because if by chance I've made a mistake, and you've seen how often I make mistakes, so I don't really trust myself. It's more of a trust issue of me than you, but that's why I recommend going back to the original, because even with this one step right here, there's a slight chance that we could make an error, and we won't know that error if we use an equation that produced what would be an erroneous solution right there. So on this equation, a little bit of work to do on this one. We want to force those coefficients either of x or y to be opposites. That will eliminate one of the two variables for us. Now, I would notice, and whether this is easy or not is really up to you, but I noticed that the 12 is a multiple of 4 right here. Some of you may have said that, well, the coefficients of x are already opposites. It doesn't matter which one you choose to eliminate. I'm just going to choose to eliminate the y's, just because it's the first one that I saw. I saw the relationship between the 4 and 12 first. So I'm going to choose to eliminate the y's in this case. All right, so that means that I need the coefficients of the y's to be opposites. Now I know that 12 is a multiple of 4, and so I'm going to not only multiply the 4 by 3, but I'm also going to multiply by -3, so it will change that sign of the 4, okay? Now remember, you got to multiply the entire equation, though. So let's give ourselves some space here. So I'm going to multiply the entire equation here, not just by 3, but once again by -3. That's going to change the equation into, and I am distributing it to every single one of the terms, and that's an important part here. Because that is our principle of equality. If I do it to these two terms, I got to do it to all the terms. You can't just do it to one or a couple. You got to do it to all of them. So that'd be 3 times 5x, -3 times 5x, which would be -15x's. Then -3 times -4, and this is the key point right here. It gives us that positive 12y, and you could right now compare it with this -12y to see that it will eliminate, and then it would equal -3 times 14, which would be -42. Okay, we didn't do anything with that second equation, so it just stays the same right there, like this. But now that I have that, I am ready to eliminate the y's. And I'm going to do that by adding each of the like terms together on this one, and then we'll see what kind of new equation that gives us. Well, the x's, I got -15x's plus -2x's right there. That's going to give me -17x's. And then just as we planned, the 12y minus 12y will zero out. And then this will equal -42 plus 8, which looks like that's going to come out as a -34. Oh, okay, that's going to come out very nice, because now when I divide both sides by the coefficient of x, which is -17, I get an x value that is 2. So right now I have an x value that's 2 in the ordered pair. That should be the solution to this system. So it's going to be a true statement for both equations. And so I can go back and I can replace the x into either one of these two equations. Doesn't matter which one. And again, we're avoiding using this manipulated equation that we used just in case we did some multiplication incorrect. Although I think it's good, okay, but we just want to make sure. So I got 5x minus 4y equals 14. I'm just going to choose the top one. I generally choose the top one if I don't see any, that one equation is going to make it easier to solve. But yeah, it may take some experience to analyze that fairly quickly, but for now, I can just choose either one. It doesn't matter which one you choose, but I'm going to choose the top one. So x here is going to equal 2, and then I'm just solving this equation right here for its corresponding y value. So 5 times 2 is 10. So 10 minus 4y equals 14. I need to get rid of that 10, zero it out. So I'm going to subtract 10 from both sides, and that will zero that out. So I'll drop my -4y, which equals 14 minus 10, which is 4. And then divide both sides by -4, so that gives me y equals now -1. So that should be my y value. Let's just check to make sure it's going to work. Again, I'm not putting it into the equation just for the sake of time, but I can do it in the calculator. Okay, so 5 times x, which is 2, minus 4 times -1, and I push enter, I get 14. So that first equation checks off with these two values. It gives a true statement there. The second equation, -2 times the x, which is 2, minus 12 times the y, which is -1. I push enter and I get 8. So that also gives us a true statement. Now I know for sure that 2, -1 is, in fact, the solution to the system. If it were a graph, that's where the two lines would intersect. All right, here's this system of equations. 4x plus 2y equals 5, and 2x plus y equals -1. Okay, so let's try this one again. They're both in the same format, which is great, okay? It does save us, maybe not a lot of time, but some time, okay? So we're going to use the addition method. Hey, no problem, okay? Now, the first thing I do on this one, again, we want the coefficients of one of the two values to be opposites. And usually, just like we saw with that previous problem there, is the coefficient of y is a 1, and that's a very easy value to work with. Even if the other coefficient were a fraction by chance, it'd be a very easy number to work with. So I would probably look at this one and say, hey, let's eliminate the y's. But I feel like we've done that, so I'm going to choose to eliminate the x's. Not necessarily because you have to, but because we've already seen some elimination of y's, okay? So I'm choosing to eliminate the x's. So on this one, I chose to eliminate the x's. Now I see that the 4 is a multiple of 2. Now some people say in order to get these, force these to be opposites, they kind of choose to, let's say this equation I'm going to multiply by this coefficient of 2. And then this equation I would multiply by this coefficient of 4. And that would in fact force the coefficients to be the same. You just have to make one of them negative to make them opposites, okay? Now I see that the 4 is a multiple of 2, so I'm gonna work with that, okay? So I'm gonna take the second equation, and I want that 2x to change into negative 4x's, okay? So I'm gonna multiply this equation right here by negative 2. Why negative 2? Because when I multiply negative 2 by 2x's, it will give me the opposite of 4x's, all right? So what does this do for us? All right, so we're going to distribute this negative 2 into all three values here. So again, that's principle of equality stuff. Negative 2 times 2x's there would give us negative 4x's. And then negative 2 times 1y would be negative 2y's. And this would equal negative 2 times negative 1. And this is where we see a lot of mistakes. It's not a huge mistake, but it's common enough. Negative 2 times negative 1. A lot of students just put negative 2 right there. Maybe they miss one of the negatives or something like that, or just a brain fart in general, but that should be a positive 2 because it's a negative times a negative right there. Now, we didn't do anything to that top equation. So it still is 4x plus 2y equals 5. Now, on this one, we chose to eliminate the x's, but yeah, as we talked about there, I did eliminate the x's, and that's great. It's just right here I got 2y minus 2y. That'd give me this many y's, 0 of them, which I do want to account for, and I guess I should have shown we are adding these together, right? So 5 plus 2 there is 7. Now, going back to what we saw in Module 1, which was quite a while ago, but what can I multiply by 0 to get 7? There's nothing. This is never true. Yeah, I guess I should be careful not saying nothing, because then that could be interpreted as 0, you know, but it's just never true, all right? This is never going to be true, at least not with any real numbers. So this one would say no solutions, or as we've seen on the homework, it comes out as a DNE. And I actually kind of like these problems because look how much work I had to do compared to the other problems that we did. It's not even half the work. We got to this point and we're done. Now, please, this is another common error we see on a problem like this one that has no solutions, or even if it were infinite solutions, which, yeah, we'll see. But a lot of students say 2y minus 2y is y. Now remember, you need to account for that coefficient, that it would be 0 in that case, and then you just need to stop and ask yourself some questions. This should look at least slightly familiar based on what we saw in Module 1. Now, the last thing I'm going to say on this one is, remember, since this is one of those DNE type situations, if you were to look at the graph on this one with the x and y axis like this, all that means is that the two lines, if you were to graph them, they would look something like this right here. I know that's not perfect, but the two lines, I know it's not drawn very well, but they're supposed to be parallel, excuse me, parallel, so that they'll never actually intersect. So that's what this means when we see does not exist, no solutions type situation with systems of equations. It means if you put those on the graph, they'll never intersect. So here's a nice system. Looks like you got a couple options. Choose which one you want to eliminate and then go from there, okay? But take a minute, try this one out, then we'll go over it. So on this one, once again, just because it doesn't matter which one we choose, I'm going to choose to eliminate the x's, okay? Arbitrarily, doesn't matter. I don't really see that one's going to be easier to eliminate than the other. Doesn't matter. Well, I guess you could say the x's are going to be easier just because they're opposites. We can ignore that, okay? So what I'm going to do is I need to force those coefficients to be opposites, right? Now, they're already opposite signs. I just need them to be exact opposites. So just like I talked about in that last problem, I'm going to take this 5 coefficient and multiply this top equation by that coefficient. This is almost kind of like I said before, forcing denominators to be the same. This is one of the strategies we see. So distributing that in there, 5 groups of negative 4x's would be negative 20x's. And then 5 groups of x's. 5 groups of negative 5y's would be negative 25y's. And then this would equal, again, you need to make sure you multiply the 5 there by that constant, 5 times 21, which would be 105. Okay? And then I'm going to take this, I don't really care about the negative, just the 4 part, and I'm going to multiply this second equation, all the terms, by 4. So by distributing that into this equation, it's going to change it just the way it looks, not its overall value, but 4 groups of 5x's would be 20x's. And we see now that the coefficients of x, just like we wanted to, they are opposites, which will force them to eliminate. 4 groups of negative 2y would be negative 8y. And this would equal 4 groups of 15, which should be 60 right there, okay? So yeah, if I needed to make the 4 a negative because like the y's coefficients are the same sign, you may have to do that, all right? But I didn't need to do that just because I chose the x's. I didn't really realize that I was going to do that in the beginning, but it doesn't matter, okay? You just need to force them to be opposites. So now that they are opposites, I can start adding the like terms. Negative 20x's plus 20x's, that zeroes out, eliminates, just like we wanted it to. And then negative 25y's minus or plus negative 8y's, however you want to look at it, it's going to be negative 33y's. And then this would equal 105 plus 160, which is 165. So that's a nice equation, which we can solve pretty quickly by dividing both sides by the coefficient of y, which is negative 33. It's kind of big, but that's doable. Y here is going to equal negative 5. So that's the first value I get in my ordered pair, which will be my final answer. The y value here is negative 5. So like we talked about before, I don't really want to use the equations that I manipulated right here. I want to use the originals just in case I made a mistake right here. So I'll just choose the top one. Some people like to choose the bottom one. I just don't see that there's any advantage to choosing one over the other. So I just go with the top one here, okay? Negative 4x minus 5y equals 21. So I'm going to replace the x value, the y value rather, with the y value found, and that is negative 5 there. So y now becomes a negative 5. And I'm just solving this equation now for x. Okay, so negative 5 times negative 5 is positive 25. So negative 4x plus 25 equals 21. Subtract 25 from both sides. And it's going to zero that out. Drop my negative 4x, which now equals 21 minus 25 is negative 4. Divide both sides by the coefficient of negative 4, and I get x equals positive 1. So I end up with 1, negative 5. And just a real quick check. I'm not going to actually write these out, but negative 4 times 1 is negative 4. And then, of course, we see in that plus 25 is 21. That checks off. What about 5 times 1 is 5, minus 2 times negative 5 is negative 10. 5 minus negative 10 is 15. That's true. So now I know for sure that the ordered pair that we found here, 1, negative 5, is actually correct. It's the solution. It makes both equations true statements. So just again, that would mean that if you were to graph these two lines, they would both intersect. They would come together at 1, negative 5. All right, here's another system of equations, and we notice right here that none of the coefficients are opposite. So it's going to take a little bit of work here, and you can analyze this. Now, some of you, just like we saw a couple of problems ago, I see that the 4 is a multiple of 2, but it doesn't matter which one you choose to eliminate. Even though that one I think would be more convenient because we wouldn't have to necessarily do anything with that bottom equation. I'm going to pretend like we didn't notice that, and I'm going to choose to eliminate the x's, which will force me to manipulate both equations there. Okay, so I'm going to eliminate the x's in this case. Let's give ourselves some space there, though. All right, so what I'm going to do, and I think we've seen this already, but I'm going to take the second coefficient of x, because I'm choosing to eliminate the x's. I don't care what the coefficients of y are now. And I'm going to multiply that coefficient by the top equation. Now, that means the entire top equation right there. So distribution, I'm not going to show that, just really for the sake of sloppiness right here. But 5 times 6x's would give us 30x's there for the first distribution. 5 times negative 2y's would be negative 10y's. And then 5 times 4 would be 20. So this is our new equation. We've changed the way that this original equation looked, but we did not change its overall final value. It's still the same equality, it's just shown in a different way. Now you'll notice back here, so I've multiplied the top equation by 5. Now we need the coefficients to be opposite. So the 6 was positive, the 5 is positive. So even though I'm going to multiply the second equation by the first coefficient, 6 here, I'm actually going to make it a -6 so that it will force those coefficients to be opposites, okay? So -6 times 5x's would be -30x's. See how that forced the coefficients to be opposites now? And then I got -6 times -4y's, which would be positive 24y's. And then this would equal -6 times -1, which is 6. And now, just like we showed, the coefficients of x, the x's are opposites, so I'm ready now to start combining all the like terms here, okay? So 30x's minus 30x's, that zeroes out just as planned. The y value is -10y's plus 24y's would be positive 14y's. And then 20 plus 6, that should give us 26. Yeah, it looks like we're going to end up with a fraction on this one because I'm ready now to divide both sides by 14, which is going to simplify that fraction. It looks like it's going to be 13/7, which is not a super pretty value, but it's workable, okay? Because especially with the calculators we have, we know that we can force the calculator to do that work for us. So there's the 13/7 in my ordered pair. And now that I have that y value, I'm ready to solve for the corresponding x value. And I don't see that either one of the two equations, again, is easier to work with. So again, I'm just going to choose the top one. You could choose the bottom one if you want, okay? So 6x minus 2y equals 4. But now I'm going to replace that y value with the y value we found, which was 13/7. Like this, okay? So let's see. 2 times 13/7 would be 26/7. So that's got 6x. And then the 26/7 was negative because of the minus sign right there. And then this is going to equal 4, right? So at this point, I got to add the 26/7 to both sides just to zero that out. So 4 plus 26/7 there. And this will give us, that'll zero that out, but I need to drop my 6x's. And for the 4 plus the 26/7, I'm going to use my calculator for that one. So my calculator gives me 54/7 there. And then I still need to divide both sides by 6, though. So divide by 6. That's a divide by 6 there. Phantom 1, x then equals 54/7 divided by 6 in the calculator gives me 9/7 there. Okay, but I still will check this. Okay, I'm just putting it in my calculator. Yeah, and I just put them both in my calculator. I found that 6x minus the 2y with the values we found is 4, so that checks off. And then 5x minus 4y with these two values is actually -1. So that indicates that we actually did this correctly. And that's my solution there for these equations. Again, this is where they would intersect. And we can see that it'll be kind of difficult to graph these, especially in sevens, on a graph, because of the fractional parts on that. So on this one, okay, one of the equations has fractions in the equation. The first thing I would probably do on this is eliminate the fractions. Now, I'm not saying just get rid of them, like, you know what, I freaking hate fractions, so I just don't want to look at these suckers anymore. No, see, now I've changed the actual value of the original problem. So I can't just do that. All right, now there's an easy way to get rid of those fractions, so especially since the denominators match like this. And so since we're seeing some like this on our practice problems, I would assume that there's going to be problems like this on the homework as well, okay? Now, if there were different denominators right there, then I would find something that I could multiply both of them by to get rid of them. And I may make phantom 1s on that. All right, so first thing I'm going to do on this, and this is going to be convenient, kind of randomly, but I'm going to take this equation, and I'm going to multiply all the terms by 3, because I got two denominators that are 3. If one was a 3 and one was a 6, I'd multiply by 6. If one was a 2 and a 5, I'd multiply both by 10. Well, all the terms by 10, okay? But in this case, it's just a 3, because if I took, and this will transform it, but 3 groups of 2/3 is going to be 2 of those x's. Same with 3 groups of 2/3 y's, that would be positive 2 y's right there. But again, don't forget your final distribution here, because whatever you do to one side, you gotta do the other side. 3 times 2 is 6, kind of fit that in there. And then the top equation, yeah, we didn't really do anything with it, so it stays the same, okay? Now, I do want that space right there, okay? But what happened in this process is by getting, or forcing the fractions to be no longer fractions, I now have a coefficient that is opposite of each other. The 2y value of the 2y coefficients, there we go, are opposites. So I can go straight into adding all of my like terms here, okay? So 4x's plus 2x's, that'd be 6x's. The negative 2y plus 2y, that zeroes out, just like we wanted it to. It eliminates, if you want to say it that way. And yeah, it does sound better if you say eliminate, but whatever. 6 plus 6 is 12. And now I just solve this, I'll divide both sides by 6 to get x equals 2. So there's my x value in the ordered pair. X equals 2. I just need the corresponding y value. And it doesn't matter which of the two equations I choose. I mean, I'm going to avoid the fractions though, so I'm going to go with the top one there. Let's make this 4x minus 2y equals 6. And I now know, that, or I think the x value anyway is 2. So I'll replace the x with 2 right there. All right, from here we're just going to solve that equation. So 4 times 2 is 8, minus 2y equals 6. I'll subtract 8 from both sides to solve for the y's here. So last thing on this one, to solve for the y's here, divide both sides by negative 2. The coefficient of y, which makes that y value 1 right there. So looks like we end up with 2, 1.
What?
All right, last thing I'm going to do is just kind of do a quick check. 4 times 2 is 8, minus 2 times 1 is 2. 8 minus 2 is 6. That checks off. 2/3 times 2 is 4/3. 2/3 times 1 is 2/3. 4/3 plus 2/3 is 6/3, which is 2. So that second equation checks off as well. Now I know for sure that the ordered pair that we found is, in fact, the solution to the system. I'll mention this. Some of you, like when we were solving equations and the equation had fractions before, some of you that had tried to use this, I think it's even on the reality check. Hold on one second. For the reality check, we saw some fractions like this. And you saw that they only multiplied maybe 2 of the terms by whatever it is that they were trying to change the coefficient into, or whatever the fraction was. They forgot to multiply one of the values by the same value. You got to multiply all the values if you're going to use this type of method right there. All right, let's get started on this one. And I guess we eliminated the y's on that last one. Let's go ahead and eliminate the x's on this one, okay? So again, it doesn't really matter which one you choose to eliminate, but I'm going to eliminate the x's. That's my goal on this. So once again, you could say I'm going to make the coefficients 30 because it's a common multiple of 10 and 15, but let's pretend like we didn't know that. So once again, I'm going to take this coefficient of 10 and I'm going to multiply it by the top equation, okay? So distributing that into each term, 10 groups of 15x's would be 150x's. I know these numbers are big, but you'll see it's not going to matter. And then 10 groups of 6y's would be positive 60y's. And this would equal another 10 groups of 15, which is 150.
Can we just do it from...
And then on this one, I'm gonna, the second equation, I'll multiply by the other coefficient of 15. So 15 groups of 10x's, that will transform that into 150x's. In fact, at this point, I see that they match, so I'm gonna make that negative 15 instead. So instead of that being a positive 150x, it's a negative 150x. And then negative 15 groups of 4y's would be negative 60y's, which now equals negative 15 times 10, there's negative 150. So now when I go to add these together, the addition method, right? What happens here is it does eliminate the x's just like we had planned, but I got 60y's minus 60y's, which is this many y's, 0 y's. And then 150 minus 150 is also 0. If we go back to what we saw in module 1 here, I know that anything times 0 is going to be 0, so this is actually just going to always be true. Always true. So that would indicate that we have an infinite number of solutions on this. So I'll go and write that in. Now you'll notice that I know that the answer is infinite solutions because I only had to solve for the y's. A lot of the time the question comes up, don't we have to solve for the x's? No, because since we know any y value will work, any any corresponding x value that makes these true will work. So we don't want you to have to list all of them because there's so many, I mean, unless you're Chuck Norris, but infinite solutions, that's all we want. Now, just as a quick reminder, for infinite solutions, okay, if you were to put this on a graph with the x and y axis like this, then your graphs will look something like this here. So, I mean, and that's really just representative of the first line there, but then you'd have the second line that would just pretty much go right on top of that right there, okay? So it just indicates that the two lines will intersect everywhere, which means that there's an infinite number of solutions. And of course, we have no expectation that you actually list all of those infinite solutions. So that's just it right there. All right, so another addition method, and yes, this one will require some distribution in the beginning, okay? Just please be careful because it is common error for students to distribute this one to all three terms right here. No. Remember, distribution is multiplication, and it's only being multiplied by this set of parentheses right here. All right, so let's go and start with some distribution on both. So I got 5 groups of negative 5x's. Going to transform this into negative 25x's. 5 groups of, you can show the phantom 1 right there if you'd like, but that's going to be positive 5y's. This equals negative 3. I can do better 3 than that. There we go. And then the second equation, I'm distributing the 3 into the parentheses. So that's going to change this one into 3x plus 18 equals 2y. Now, I know I've said this before. Don't get so robotic that you're like, I got a 5y's plus 18. That'd be 23y's right there. Okay. Well, no, these are not like terms that you can combine. In fact, both equations are not in the same format. The top equation is in standard form, but the second one is not. That is garbage. So what I'm going to do is I'm actually going to take that second equation, this 3x plus 18 equals 2y, and I'm going to change it so that it is in the same format. So it will now be the green equation. The top equation won't be changed at all. So I'm going to keep that negative 25x plus 5y equals negative 3. So on this one, I'm going to say, I want the y's with the x's over here and then all my constants on the right. So I'd say, look, I'm going to have to subtract 18 right there to zero that part out. And then even the 2y, I'd have to subtract that. Okay, so I'd say, and I'm kind of stacking that with the x's, knowing that they're not like terms, so I'm going to have to keep them separated. So that would give me 3x's minus the 2y's. Again, they're not like terms to combine. These y's zeroed out, and then I'd have the negative 18. Now, this is in the same format as the other equation, so I can look at them together. So 3x minus 2y equals negative 18. So this right here, between the red and green, this is my new system of equations, and I just, as of right now, I'm going to ignore the rest of that garbage, okay, because it was all work to get to this point. In order to force the two equations to have the same format, just like we saw was the first step, which isn't always necessary, but from time to time it is, okay? Now, looking at these ones, I see the 25 and the 3. I would say that's not going to be very fun to work with, but the 5 and negative 2, it's not going to be fun, but it's easier work. So I'm going to take this top equation here, and I'm going to multiply it. I'm choosing, by the way, to eliminate the y's. I should probably write that down. Eliminate the y's. Okay, so that's my goal. And that means I have to multiply the top equation by the coefficient of y, which I'm just going to say is 2, right? Because they're already opposites, so that's good. So that's going to change this one. 2 times negative 25 is negative 50. That's x's, sorry. And 2 times 5y's is 10y's. And then 2 times negative 3 would be negative 6. And then the second equation there in green, I'm going to multiply that by the coefficient of y, the 5. So 5 groups of 3x's would be 15x's. 5 groups of negative 2y's, negative 10y's. And then 5 groups of negative 18, negative 50, negative 90. Okay? And yeah, what this did for us is it just forced the two coefficients of y's to be opposite, so they will eliminate just as planned. So when I add them together, they will zero out. But the x's, I got negative 50x's plus 15x's, which would be negative 35x's. And then this will equal negative 6 plus negative 90, it'd be negative 96. This isn't going to come out very pretty, but my calculator knows how to simplify it for me, because I can just divide both sides by the coefficient of x here, negative 35. So in my calculator, I have negative 96, whoops, all over negative 35, enter, oh. And so that, it actually didn't simplify at all, other than to get rid of those negatives right there, 96/35. Well, fair enough. Now again, that I'm not expecting that, so just kind of check my work here before we continue. And I would rather check now than to get to the end and be like, I got to check everything to make sure I didn't make any mistakes, which you've seen me do quite often. So, well, looks like I copied everything good. I think we're in good shape. So I'm gonna go back to one of the original equations. Again, I'm probably gonna choose the second one just because it's a regular x right there. So 3 multiply the quantity x plus 6 equals 2y. All right, but I'm gonna replace the x there with 96/35, which is positive. 96/35. All right, so let's see what we get out of this. 96/35 plus 6, and that results in 306/35. Now,
You can simplify.
so 918/35. Last thing I'm gonna do here is just divide both sides by 2. So let's divide by 2 here, divide by 2 there, divide by 2 on my calculator, because I don't want to do that in my head. I know some of you want to, but I'm not gonna. I got 459/35 on this. That's my y value, by the way. And no, it's not very pretty, but we'll check to make sure it works. But let's go and write this in here: 459/35 and 96/35. Okay, so I'm going to put these into both equations, see that they work. Okay, real quick. So I checked this one. The top one gave me, when I replaced the x and y with these values, because it's too long to repeat, I got -3. And then the bottom ones, they gave me a pretty ugly fraction, but the left side gave me 918/35, and then 2 times the 459/35 was also 918/35. So that would be true, which would indicate that this is the actual solution.